Hi friend, welcome again. In our previous lecture we have discussed about BJT, configuration of BJT and biasing. In BJT we have discussed that common emitter amplifier is used as an amplifier. Now today we will discuss about amplifier, that what is amplifier. In that case, amplifier is a device amplifier is a device used for enlarged reproduction of received signal. And also this process is known as amplification. Here we have used the word enlarged reproduction. What is enlarged reproduction? In that case, enlarged reproduction means increment in the magnitude of the signal, and this is the reproduction. That's mean it's not giving a signal or generating a signal of high amplitude, but it is developing a signal with the help of another signal. That's mean a signal is being modified. So that's why here we have used the word of enlarged reproduction of received signal. Now, according to law of conservation of energy, energy cannot be generated, cannot be destroyed. Energy cannot be generated, cannot be destroyed. But here the amplitude of the signal is being increased. In that case, how it's developing energy. So that's why we used or DC fixed input for amplification of input signal. Now, To understand the process of amplification, just take an example of water tap. Suppose this is a water tap. This is used for output water. Here input of water, and at this place we have used a controller which will control the amount of water. Input signal. Input water, output water. From this diagram, suppose the way of water is completely closed. In that case, the input provided by the water tank will not pass through this stopper. So here the output will be 0. And suppose you have provided small input, that's mean a small path is provided to cross the water. In that case, we will get a small amount of water, and you are going to open this tap completely. In that case, the flow of water will be increased. But here we have applied a fixed input of the water, which is coming in the form of output. Water is coming to the output, but the amount of water is controlled with this input signal. Similar in the case of amplifier, we have supplied a fixed input like the input water, and the signal which is to be amplified is provided as an input signal, and we will get the output which will be amplified. So this is the basic concept in the amplifier. So that's why here the law of conservation of energy is also followed. Now amplifier can be called as voltage amplifier. Suppose which kind of amplifier we are using. In that case, first of all, the current will be amplified. In that case, the amplifier will be known as current amplifier. Current amplifier. Second thing, voltage amplifier. And third, power amplifier. Current amplifier is the amplifier which will improve the current. Voltage amplifier which will improve the voltage of input signal in the term of output, and the power amplifier is used for increasing the power of input signal. And we also know that the device is operated on a particular frequency, and the range of frequency which is operated through an electronics device or any device, that is known as bandwidth. Suppose a device works on frequency from F1 to F2. So frequency range equals to F1 to F2, and bandwidth equal to F2 minus F1. Similar, amplifier is also used on the particular frequency range, so that's why amplifier is defined on the basis of its operating frequency. In that case, amplifier will be direct coupled amplifier, audio amplifier, video frequency amplifier. So let's define that on the basis of frequency. Direct coupled amplifier. Audio frequency amplifier. Video frequency amplifier. And radio frequency amplifier. Here, the amplifier is defined on the basis of the energy type which should be amplified. Then it will be of three type: current amplifier, voltage amplifier, and power amplifier. In case of current amplifier, the current of the input signal will be amplified. In case of voltage amplifier, voltage of the input signal will be amplified. And in case of power amplifier, current and voltage both will be amplified. Now, on the basis of frequency, the amplifier is classified into four parts: direct coupled amplifier, audio frequency amplifier, video frequency amplifier, radio frequency amplifier. Direct coupled amplifier is used for amplify the signal of low frequency. In this, frequency low, so it is low frequency amplifier. In case of audio frequency amplifier, the signal of 20 to 20 Hz to 20 kHz. It's mean that here the frequency range is audible frequency range of human being, that is 20 Hz to 20 kilohertz, and the video frequency amplifier is used to amplify television signal of few megahertz. This is used for few megahertz, and this is used in television signals. And last, radio frequency amplify the signal from 20 kilohertz to 20 kilohertz to few megahertz. So these are the types of amplifier on the basis of operating frequency and their frequency range. So in case of direct coupled amplifier, the amplifier work on low frequency. Audio frequency amplifier, this amplifier works on 20 Hz to 20 kilohertz. Video frequency amplifier for few megahertz. And in case of radio frequency amplifier, the amplifier works from 20 kilohertz to few megahertz. Now, all the amplifier is made with the help of some electronics component and also with the help of some electrical component. In case of electrical component, there will be resistance, inductance and capacitance. That means we will use resistor, capacitor and inductor. So we can define the amplifier on the basis of component used for make it. So in that case, amplifier will be resistance capacitance amplifier. On the basis of passive element used in amplifier, it is known as RC amplifier. That's mean R is used for resistance, C is used for capacitance. In this amplifier, we will use resistance and capacitance as the element of the amplifier. In that case, our amplifier is known as RC amplifier. Similarly, we can use resistance and we can use inductance and capacitance. In that case, amplifier will be LC amplifier. This is also known as LC coupled amplifier. And when we will use electronics device to make our amplifier, in that case transistor is used, so the amplifier is known as transistor amplifier. Here we are dealing in electronics, so it's necessary to leave RC amplifier and LC amplifier. Now we are going to define transistor amplifier. In that case, transistor amplifier, when amplifier is made using transistor, it is known as transistor amplifier. Here the basic reason why it is known as transistor amplifier, that we are using the transistor to make our amplifier. Now in case of transistor we have deal with only BJT, so that's why here we will make our amplifier with the help of BJT. And in case of BJT it's necessary to fix the biasing, that's mean quotient point or operating point of the transistor. On that basis mode of operation will further classify the amplifier in its several category. So here we classify class A amplifier, class B amplifier, class C amplifier, class AB amplifier, and class C amplifier. We will deal with AB, and C type amplifier. In case of transistor, we know that we need to fix its operating point, which is essential for using or transistor in any circuit, and the operation of the circuit is dependent on the operating point. So that's why on the basis of operation or mode of operation, the transistor amplifier is classified in class A, class B, class AB, and class C. So now we are going to discuss about class A amplifier. So in case of class A amplifier, see in this diagram we have used common emitter circuit, as we have discussed in previous lecture that the common emitter is used as an amplifier, and the operating point of the transistor, Q point or quotient point, is in mid. It is in mid. So that's why in class A amplifier the operating point will be in mid of the DC load line. Operating point will be in mid of DC load line. See, this red line is representing our DC load line, and this point Q is operating point. In this case, here the horizontal scale is representing collector emitter voltage, and this vertical scale is representing collector current. At zero input, collector current is high, and at the maximum input, collector current is zero. And in this fluctuation, we have selected that the midpoint of our DC load line as an operating. So see, here we are varying the input signal in this range, and the variation in the output signal is in this range. Now this is the cutoff region, but before cutoff region we are getting our complete cycle as an input, output, and also we have provided the complete cycle of input. So that's why in class A amplifier we will get complete cycle. And this is working in active region. That's mean it works in active region. There exists a collector current IC even the no signal condition. Here we have not provided any signal. In that case also there will be collector current, and that will be maximum, and when signal is applied the amplification given by this amplifier is maximum and there is no distortion. However, it has low power and low frequency. Low power and low frequency. The worst condition in this class A amplifier is that when input signal is 0, then output current IC is maximum. This will dissipate maximum power. It may be seen in this diagram that when we have provided 0 input signal, here the input is 0, in that case also the maximum output is in the term of IC, which will dissipate more power that is not desirable. So under no signal condition, no signal